we're going to kind of camp on. Okay. I have them grouped in themes, guys. The word problems are somewhat in themes. So when I made this booklet is actually completely different than last year's. I had one made already, but this time I grouped it in themes. So you're going to see a bit of a pattern. So let's dive in. So now that we have learned how to solve for sides, angles, using sine, cosine law, we can start solving word problems. In general, right, I'm just going to suggest you follow these steps, right? Draw a label diagram, of course. Assign letters to each angle. You're choosing, because I'm not going to, sometimes I'm going to tell you, hey, this is point A and they're traveling from point A to point B, so it's quite easy to just go ABC, right? Sometimes I tell students this, okay, listen carefully. It's okay to start your diagram over. It's okay, guys. Erase it, start over. Or have some scrap paper, maybe on a test quiz, and just start drawing this thing. Like, you know what, it doesn't make sense the way I have it. Okay, oh yeah, now I see where it's going. And then you start on your clean paper, right? So maybe this is the time that you want to use scrap paper. If it seems that you're stuck, right, I don't know what to do, then start solving for something that you see, right? I can definitely solve for this side, and then move in, right, onto the unknown side angle that is actually being asked for, okay? Show how you set up and solve for missing dimensions. Round final answer to 2 decimal places, nothing new there. Including angles. I know you're used to probably from IPR, a lot of teachers just set whole numbers for angles. But in grade 12 provincial, everything is two decimals, right? Very few exceptions. Remember to check if your answer is reasonable. So this is actually an important step, right? Before you move on, it's like, does it make sense to get that angle? Does it make sense to get that side length, right? And so I don't think you need this on your study sheet, but this is just to guide you, right? I don't want you to use up too much study sheet space. So let's do some definitions. Concepts, review. You should have heard of these before, but angle of elevation, angle of depression, very important, right? So my classic diagram is, you can feel free to laugh at my diagrams, that's okay. But there's always, the important thing is the horizontal, right? There's always a horizontal that touches the angle of either elevation or depression. Remember that, horizontal, right? And so whether you're looking up at a bird, plane, kite, balloon, it doesn't matter, right? How was Mr. Hudson? He was good, wasn't he? He used to teach here. I don't know if you remember him. He was my sub on Friday. So there's the angle of elevation is formed between that horizontal, right? Angle of elevation. I call that would be it right there. And angle of depression, let's say something's crawling on the ground. I'm just going to use a little bug here. That, right? That right there between the horizontal and the line of sight looking down, this would be the angle of depression, right? And I'll tell you later why that's important, because there are some very common errors made here, especially when it comes to angle of depression. That one is the most common mistake students make. But I'll make sure you're going to be champs by the end. You're not going to make that mistake. Okay, I'm going to show you how that's done. Supplementary angles. Angles whose sum is 180 degrees. Angles whose sum is 180 degrees. So classic one is, just follow me here. So imagine you're here and there's a tree, right? And you're looking to the top of that tree. And then you either move closer or there's somebody standing closer. So you move up closer and you look up again, right? And let's make a dashed line going to the trunk, right to the bottom of the tree like that. This is where it's going to come in handy to recognize supplementary angles or straight angles. Is that if this is 50, what's this one going to be that remains to the straight line here? 130. Thank you. Right, we know that those two add up to 180. So at first, it's going to seem like the 50 is useless. It doesn't give me anything. But yeah, you can actually easily find the angle inside the triangle. So very important. I would argue that complementary shows up as well. I will talk about that a little bit later because we're going to do compass direction questions. Guy wires. What are guy wires? They're just wires that, so if you have your hydro pole, right, you often see wires on, this is the ground, right? So that's just a wire that's supporting some kind of structure. Sometimes you have a flag, right? A flag pole supported by two guy wires, right? So you've got one there and one there. Right? So guy wires are just wires that support some kind of structure, an antenna, fence post, you name it. That's what it is, right? And I have a feeling that you've heard of it before, right? But it's just, that's what it is. Because a lot of the word problems will not have a diagram, so you need to know what's happening, right? That's about it for review. Now we're going to dive in and draw our triangles. But we're going to stick to the theme. You're going to see, by the way, let's make sure you understand. Unless they say that the flagpole is leaning, we can always assume that there's a 90 there. Okay, there's a 90 there, there's a 90 here. Unless the question says this pole is not straight, it's leaning from the vertical, we assume that there's a 90 here and 90 there. So, Mr. Dixon, this is a right triangle, isn't it? Yes, it is. And that's why I also taught you how to find the height, right? If somebody asks you how high up the pole is this wire attached to, we know how to find the height, right? Same here, we know how to find that height, so that's why it's going to come in handy. But I'm not going to use SOHCAHTOA because a lot of you, not you, but in the past when I brought back SOHCAHTOA, students would always default to that one. They would just be like, oh, I remember that one. I'm going to use that to solve everything, and you can't. Most of the time you can't. So page 36. Monday morning, eh? I'm just going to tell you one thing. I noticed as I worked through this booklet, I had to do the whole thing again. Fun. Every time you see something like homework page, this and this in the workbook, you no longer have a workbook. This is it. Like notes and workbook is all one. Okay, so just ignore those. Just ignore them when they show up, because you might wonder, hey, I never got a workbook. This is it. It's just one. Okay, that's why it's a bit thicker. So here we go. A radio antenna supported by two wires on opposite sides. So we should understand the post is in the middle, right? The wires are anchored. That's probably important. Wires are anchored 6 meters apart. So from one wire to the other wire. Anchored means they're attached to the ground, right? If you anchor something, an anchor goes to the bottom, right? One wire has an angle of elevation, right? One wire has an angle of elevation of 62, while the other one has an angle of elevation of 75. Okay. So we're going to sketch the scenario, determine the length of each wire, calculate how far up the pole the wires are attached. So I'm kind of walking you through all of it. Can you just quickly copy this down? I wanted this as well on there. D, just never made it to the page 38. I'll give you the answers. I'll write them down, but just try them right now. It's very similar to the one we've just done. between Agnes. You should get 457.28 for the first one, and B should be 293.93. That's it. I'm not going to do anything new today. So for homework, you want to write it down right here, or maybe just come with me to page 39. Okay, and at the top of that, oh, it is recording. Okay, I'm just going to say this: homework, page 39. So this one here to 41. And if I were you, I would focus on word problems primarily. Word problems, right? Not that you don't have to. If you want to do the other ones, I will add that too. But before, I'm getting you ready for this one, okay? Notice what it says there. Angle of depression, angle of depression. You got lots of space, more than you need on this one. If you want to write down the common error, this one I find helpful. I find helpful writing down the common error so you don't fall into the trap, right? If you want angle of depression, let's say it's 30 degrees, this is not it. Some students, because hey, it's the line going down, right? So they put the 30 in there. That's wrong. This is not right. It's always between the horizontal and a slanted side. So the 30 is actually supposed to go there. That is right. This is wrong. Okay? So when you draw your diagram, if you see this happening, you're not doing it right. Okay? I'm going to post this key, especially this one I want you to focus on quite a bit. And then 40 to 41, look for the word problems. Okay? Maybe we have a little bit of time, so I'm just going to get you to go to 41. Watch this. They give you speeds right on page 41, question 4. You travel 420 kilometers an hour, and the other plane travels 375 kilometers an hour. How far apart are they in 2 hours, right? They're 2 hours later, something is true. So I don't know if you need this one, but distance, this is physics, right? Distance is time multiplied by speed. So that will give you, right, the length of one of the sides. And that's it for today, guys. If you want to start working through it, go for it.